All right, guys. So I wanted to kind of go over the assignment for electron configurations, writing shorthand. All right, so this is the noble gas configuration. But I just wanted to kind of start with going over this information here, all right, on labeling. So when you look at, let's see if I can do this here. So how to write electron configurations from the periodic table. It says allow each box on the periodic table to represent an electron. Okay, so each box is an electron, and you read from left to right. So we're going to look at nitrogen, chlorine, and rubidium. All right, so to do that, what they're saying is each box, okay, is an electron. Okay, so I'm just going to go ahead and put like an electron here. Okay, and then an electron over here. Okay, so each box is an electron. Now remember, this is our first energy level, and it's the S. So there's a spherical and there's just one orbital. All right, so this is 1s1. Over here, this is 1s2. So this number here, okay, is going to tell us how many of electrons we have. So when I go down to the next level, okay, right here, I have an electron and an electron. So this right here is going to be 2s2, all right? And remember again, this number here is the number of electrons. Now, when I come over here, again, each box is an electron. But now we're in the P block. Okay, so this section right here, okay, is the P block. It doesn't include this one. Okay, so just these 6 elements. All right. So what we have here is we're in the second energy level, so 2. We're in the p orbital, and we have 1 electron. The next one is 2p, but we're going to add these electrons together, so it's 2p2. The next one here, okay, is 2p, and I've got 1, 2, 3 electrons. Okay, so the first example, okay, is going to be for nitrogen, 1s2, 2s2, 2p3. And to check myself, okay, nitrogen has 7 electrons, so I just need to make sure that these numbers add up to 7, okay, and so that's going to be the correct electron configuration. Now, when we do this, okay, remember we're going to keep going that this is 2p4, 2p5, and then 2p6. We're going to go down to the next one. So this is going to be 3s1. Okay. Then what we're going to do is we're going to go over here. This is going to be 3p1, 3p2, 3p3, 3p4, and 3p5. Okay, so that's chlorine. Okay, so that's going to be our next electron configuration. Okay, so for chlorine, we're going to have 1s2, 2s2. Okay, we need to use those, right, because we're counting electrons. Then we're going to have our 2p6. Now we're dropping down to the third energy level with 3s2 and then 3p5. Okay, again, count up the electrons, and it should be the atomic number. All right. Now, with rubidium, okay, it's going to be a little different. Okay, it's a little harder, but what we're going to do is we're just going to kind of follow the periodic table, all right, to do this. So I'm going to start here at 3p6. Okay, so after 3p6, okay, what we're going to do is we're going to come down here to the fourth energy level. So this is 4s1, 4s2. Okay, but now we run into the D. Now there are 10 elements here. So there's 10 electrons in this space. So this would be 3d1. Okay, and then you're going to go 3d2. Okay, all the way up to here where we have 3d10. Okay, but we're not done, right? We got to keep going. So after our 3d, we run back into a 4p. So this is going to be 4p1 all the way to 4p6. Okay, so I'm just reading from left to right. Then I'm going to go down here. So I've got 5s1, 5s2. Right? We run into our D again. So this is 4d1, 4d2, 4d3, 4, 5, and 6. 4d and 6. All right. So for this one, the electron configuration is a long one. Is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, then we're going to go to 4s2. Then we go to our 3d10, right? Then our 4p6 down to the 5s2, and then we end with 4d6. Okay, so remember, I'm just reading from left to right. All right, so when we're doing noble gas abbreviations, okay, the noble gases, okay, are in this last group. All right, so they are this. Okay, so our noble gases are here. All right, so noble gases. So noble gases, okay, they have their p orbital filled. All right, so it allows us to kind of make a shortcut. All right, so noble gases, right, are elements located in group. They are going to be in group 8, and so that's right here, 8A. All right, so, oh, sorry, I think I've just got to look at my slideshow here. All right, so they include, so this is 8A. All right, sorry, get my pen back out. So they include helium, neon, argon, krypton, xenon, and radon. All right. So what you're going to do to write these electron configurations using the noble gas abbreviation, okay, is you're going to pick the closest noble gas to the element you are writing, okay, the configuration for, that comes before the element. Okay, this is really important. Before the element. All right, so what does that mean? All right, so K, all right, if we look at the periodic table, okay, K is going to be 19. Okay, so it has 19 electrons. Okay, so the atomic number is 19. Now, for 19 electrons, okay, remember to do rubidium, okay, which is up here, we had to write all of this, right? We had to write all of that up here. But I don't want to have to do that. Okay, so there's a shortcut. For krypton, I'm going to look at the noble gas that comes before it. Okay, so that's going to be argon. Okay, that is 18. So what I can do is I'm going to put a bracket with argon. Okay, that's the noble gas. And then I'm going to start, okay, at the S shell. Okay, S sublevel, the next energy shell. So this would be, it's going to be the fourth energy level, S, and then 1 electron. For magnesium, okay, magnesium has 12 electrons. Okay, so I'm going to look at the noble gas that comes before that. Okay, so that's going to be neon. Okay, so I'm looking at the noble gas that comes before the element that I'm trying to figure out. So that's neon. And then magnesium, okay, is in the third energy level. It's in the S subshell, okay, and it's going to have 2 electrons in that. Okay, so BK. Where in the heck is BK? Oh, there's BK. All right, so BK is a long one, okay? So, I'm never going to give you one that hard, all right? So I'm going to cross that off. And let's just look at bromine. Okay, bromine's a good one because it trips people up. So bromine has 35 electrons. Okay, it has 35 electrons. So I need to look at the noble gas before that. Okay, a lot of people put krypton, but krypton is after. So I have to go all the way back up to argon. Okay, and then what I'm going to do is I have to then write from there. So I'm at the 4s2. All right, then I'm going to have my 3d10, and then I'm going to have my 3p, 4p, 4p5. Okay, so make sure that you know how to do that. All right. Now, remember, ions, okay, basically are elements that have a positive or a negative charge. So elements, okay, or mini elements. Sorry, guys, I hate it when this happens. that many elements will lose or gain electrons to be like a noble gas. Okay, so noble gases are stable. Okay, they have a full outer shell of electrons. Okay, so they don't react with other elements. So elements will gain or lose electrons to become more stable. Okay, so let's see, I want to be able to do this, fix this here. Sorry, guys. Okay, so what will happen is if we're writing those electron configurations and we have a noble gas, okay, but we have an element that really isn't, okay, a noble gas, but it has the same electron configuration as a noble gas, okay, it's going to be an ion. Okay, so there's a lot I just said in that sentence, but go back and listen to it if you need to. So if two atoms have the same number of electrons, okay, they are isoelectronic. Okay, isoelectronic. So remember, atoms, okay, will always have different numbers of protons. The electrons can change. Okay, so if you have two different atoms with the same number of electrons, okay, they're not going to be the same element. They're different elements, they're different atoms, but the electrons have changed. So if there's two different atoms, okay, that have the same number of electrons, then one of those have gained or lost electrons to become like the other one. All right. So some examples. Let's see if that helps. So what are the electron configurations for the following ions? All right. So we have O -2. All right. So if we look at oxygen, okay, oxygen has 8 electrons. Okay, but this is a -2. Okay, so it's going to gain 2 more electrons, right? It's negative, so it's going to gain 2 electrons. So over here, I'm going to put plus 2 electrons equals 10 electrons. So what I have to do is write down the electron configuration for the element that has 10 electrons, which is neon. Okay, so what I'm going to do here is I'm going to write down 1s2, 2s2, 2p6. Okay, oxygen would be 2p4, but we've gained 2 electrons, so it's now like neon, okay, but it's not neon. It's called isoelectronic with neon. So although O -2 and neon, okay, have the same electron configuration, they are not identical. Okay, why? okay, because oxygen has 8 protons, and neon has 10 protons. And remember, protons is what changes the element. Okay, so now rubidium. If we look at the periodic table for rubidium, okay, it's going to be rubidium. Where in the heck are you? Rubidium. Okay, it's 44. I think. Yeah, when you start losing your vision, you need glasses. So give me a second to put on my glasses. Sorry, I wasn't ready. Oh, good. I'm glad I looked. It's ruthenium. So rubidium is 37. Okay, 37. All right. So what we're going to do is rubidium plus 1. Okay, that's a plus 1. Now, if rubidium, okay, has a plus 1 charge, it has lost, okay, an electron, 1 electron. So rubidium, okay, has 37 electrons. That's rubidium. All right. But I am losing 1 electron. Okay, so 37 electrons minus 1 electron, okay, gives me 36 electrons. So rubidium wants to be like krypton. Okay, it wants to be like krypton. So it's isoelectronic with krypton. And to write that, okay, what we're going to do is we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Okay. So now, let's look at the next question. All right. So, let's see. If we look at these electron configurations, okay, what I'm basically doing is, all right, so we need to know the ion. So I have this with a +2 charge. All right. So that means I have lost 2 electrons. Okay, I've lost 2 electrons. And so this is going to be isoelectronic, okay, with another atom. So let's look at 1s2, 2s2, 2p6. Okay, when I do that, that takes me to neon. Okay, but remember, I have a +2 charge. Okay, which means that the element that I'm looking for has lost 2 electrons. Okay, so what I do is I need to say, all right, so it's lost 2 electrons to have a +2 charge. So what I have to do, okay, is I have to add 2 electrons. All right, and so that's going to give me magnesium +2. Okay, so this is my +2 charge. right there. All right. This is neon. So I go to neon, but now I've lost 2 electrons because of my charge. Okay, so to get those electrons back, I get magnesium. All right, so the next one, all right, is phosphorus. Okay, so if we look at this right here, this configuration is argon. Okay, but we've gained, okay, 3 electrons. Okay, so we've gained 3 electrons. So what I have to do, okay, is I'm going to look at this and I've got argon, right? But the element that I'm looking for, okay, has basically gained 3 electrons, right? Because it has a -3 charge. All right, so I've got my argon, okay, and now argon, okay, remember it's the element that I'm looking for has gained 3 electrons. So what I need to do is I need to subtract 3 electrons from argon, okay, and I'm going to get phosphorus, okay, with a -3. So remember, -3 here and a -3 charge, okay, that's where I'm getting this -3 for argon or for phosphorus. I have argon listed. Okay, that's my electron configuration, but it has a -3 charge. All right, so the element that I'm looking for is P -3. All right, that's a little confusing, but spend some time and see if you can figure that out. If not, let me know. Okay, so the next one, we're going to talk about valence electrons. Valence electrons are on the outermost shell. Okay, and so valence electrons are electrons located in outermost energy level. Okay, and what's really important about these is these are responsible for bonding. Okay, so that means they're the ones that are responsible for all of your chemical reactions. So to count the number of valence electrons in the electron configuration, you must look at the highest numbered energy level in the entire configuration. Okay, then you add the electrons together. Okay, so to find the number of valence electrons, that's what you do. So, question, how many valence electrons are in each of the following configurations? All right, so I have potassium, okay, which has 19 electrons. So potassium, it's a weird one. It's a K, it's not a P, it's a K. Okay, so on the periodic table, potassium is K, and it has 19 electrons. All right, so what we have to do is we're going to write down the electron configuration, all right, for K, and this is what it is. Okay, that is the electron configuration for K. So what we're going to do is we're going to look at that energy shell, okay, that energy level, which is 4. So we have the 4th energy level, okay, is the valence shell. Okay, and just to remind you, the energy level equals the shell. Okay, same thing, basically. All right. So how many electrons do we have? 1. 1 valence electron. So there's 1 electron in the outer shell. Okay. So let's look at the next one. Okay, we've got cobalt. All right. So for cobalt, right, you got to be careful with this one. So for this, we basically had the last shell, right? But for this one, okay, the highest energy is the 4s. Okay, it's before the 3d7. Okay, so even though this one comes after it, the 3d comes after it, 4 is the highest energy level. All right, so take a minute and think about that. So this is going to be our 4th energy level. Okay, and there are 2 valence electrons. All right. So next, let's look at platinum. Okay. Now, remember, we've got this whole long thing here, right? Do I want to have to write all that out? Oh, heck no. All right. So platinum is 78 electrons. Okay. So again, guys, I'm not going to give you one that hard. Okay. So let's look at manganese. Okay, manganese is Mn, and it's 25 electrons. Okay, so what I'm going to do here is I'm going to basically, I don't have to like figure it out. I'm just going to start counting electrons. So I've got 1, 2, 3, 4, 10, 11, 12, 18, 19, 20, 30. Oh, so I went too far. Okay, so if you look at cobalt, it's 1, 2, 3, 4, 5. Sorry, manganese, it's 1, 2, 3, 4, 5. It has a 5 here. It's in the 3d5. So all of this, okay, I can get rid of. Again, the highest energy level is the 4. Okay, that's the highest shell or highest energy level. Okay, and it's going to have 2 valence electrons in it. Okay, and then neon has 10 electrons. Okay, so if you look at this one, it has 2, it's basically got 2 different orbitals, okay, in the same energy level. It's got the s orbital and the p orbital. So for this one, what I have to do okay, is I have to add all the electrons that are in that energy level. Okay, so this tells me that I have 8 valence electrons. Okay, so basically that's a lot of work, right? There's a lot of information I gave you. So go over this a couple times until you understand it. And again, if you don't understand, let me know.